this is lesson 6.4, Intro to Logarithms. So what is a logarithm? A logarithm is another way of writing exponents. So here in logarithmic form, we have log base b of a equals x. So when you write this, it'll be written as b to the power of x equals a. So note that logs with base 10 is called a common logarithm and can be written without the base. So log base 10 of x just looks like log x. So here we'll practice changing between the forms. So remember that log base b of a is equal to x is b to the power of x equals a. So b equals 7, a equals 49, and x equals 2. So when we rewrite this, you have x to the power of 2 equals 49. So next we have b, which is the base, equals 2. A is this constant, equals 32, and x is the solution on this side, so 5. So we rewrote as b to the power of x equals a. We have b 2 to the power of x to the power of 5 equals a, 32. Now we have log 1000 equals 3. So when there's no log here, this is log base 10. So b equals 10, a equals 1000, and x equals 3. So we have bx equals a. We have 10 to the power of 3 equals 1000. We have log base, next we have log base 4 of 1 over 64 equals negative 3. So b equals 4, a equals 1 over 64, and x equals negative 3. Rewritten as bx equals a, b to the power of negative 3 equals 1 over 64. Next, we'll change from exponential form to logarithmic form. So instead of going from log base b of a equals x to b to the power of x equals a, we'll just do it in the reverse order. So for the first example, b equals 5, x equals 2, and a equals 25. Rewritten in this form here, we have log base 5 of 25 equals 2. See that b equals 8, x equals 0, a equals 1. Log base b of a equals 0. This will get easier with more practice and more familiarity. b equals 3, x equals negative 4, and a equals 1 over 81. So log base of b, log base of 3 of a, 1 over 81 is equal to x. b equals 12, x equals 1/2, and a equals 2 rad 3. Log base 12 of 2 rad 3 equals 1/2. So here's how to change it from exponential form to logarithmic form. Now we'll evaluate the following logarithms using these exponent transformations. So b equals 10 and a equals 1 over 100. Now we don't know x here. Now written in exponent form, b to the power of x is equal to 1 over 100. We'll reference some exponent rules so that we know when a term is raised to any sort of negative power, we'll get a fraction like this. So this tells us that x has to be negative. So what value of x will make 10 become 100? So 10 to the power of negative 2 equals 1 over 100. So now we have log base 16 of 2 equals x. So we'll rewrite this as 16 to the power of x equals 2. So we can take this base number here and break it up. So to match this number, we have 4 of these. And because we know that the x needs to be less than 1, we'll raise it to 16 to the power of 1/4 equals 2. Therefore, x is equal to 1/4. Some logarithms are not as easy to evaluate as those we just did and will require the change of base formula. So the change of base formula says that log base b of a is equal to log of a over log of b. This will approximate each logarithm using the change of base formula. So log base 5 of 34 will be written as log base 10, 34 over log base 10 of 5. And that equals 2.191. We have a log of base 6 of 2 is log base 10 2 over log base 10 6, which equals 0.3869. Log base 20 of 4 is log base 10 of 4 over log base 10 of 20, which equals 0.4628. Now log base 8 of 1/2 is equal to log base 10 of 1/2 over log base 10 of 8. That equals negative 1/3. This is all stuff that you should be able to do on a calculator. Next, a special logarithm with base e is called a natural logarithm and is written as ln. So log base e of x is written as natural log of x. We'll practice writing each log in exponential form and then from exponential form to log form. So we have log e of x equals 4. And we follow log b of a equals x, changes to b of x, b to the power of x, changes to b to the power of x equals a. B equals e, a equals x. Actually, let's call this y for now to avoid confusion. To the power of y. A equals x and y equals 4. We'll change it to e to the power of 4 equals x. E to the power of x equals 50. So we have b to the power of y equals a. So b equals e, y equals x, and a equals 50. Written as a log, we have log base e, which is equal to a natural log. So we have a natural log of a, which is 50, is equal to x.